Hey everybody, my name is Brandon Graisley. I'm a high school math teacher. We're going to learn how to model sinusoidal situations using an equation because you can use the equation once you have it to calculate things like what will happen in the future or where does a particular sinusoidal function achieve a certain value, things like that. So the big goal is to try to write an equation that matches this situation. So let's start off with the first one here. We're going to do two examples. The first one is a Ferris wheel has a radius of 9 meters and is 1.5 meters off the ground. It takes 45 seconds to complete a revolution. Write a sine and a cosine equation to represent the height of the car after t seconds if it begins at the bottom of the Ferris wheel. So let's begin by trying to draw a graph here. Now this graph is not going to be to scale, it's just kind of a sketch to help us see where the key points are. So this is kind of my ground here where the height is 0. Horizontally we're counting seconds, so I'm going to write the variable t here. This is not in degrees, and that's going to really matter when we come up with our equation. And then vertically we have just the usual y, which represents the height. Now the bottom point, the lowest point rather, is 1.5 meters. So I'm just going to put that here on my graph, 1.5. It doesn't matter what exactly the scale is that I'm using. And then up here I'm going to put the top point, and here I'm going to put the middle point. It's just a nice easy way to show it. Again, it's not to scale. And horizontally it takes 45 seconds to complete a revolution. So I'm going to make a nice number, 8 boxes to get to 45 seconds. Okay, now let's start drawing this in. At the bottom, that's where it begins. We start here. And then at 45 seconds we're going to complete a revolution, which means we come back to the bottom. Halfway between, which would be 4 boxes in my case, it'll be at the top. And then chopping that again in half, we get to the axis here and here. So that's what the curve is going to look like. I'll just kind of sketch that in here. And then it would repeat. Now you notice I put an arrow there, but not here, because this is a real starting point. We can't continue back into negative time here. It starts at 0. Let's work on the vertical axis here. We know that the radius is 9 meters. Now, the radius of a circle is sort of the distance from the center to the outside, so that means that this point here must be 9 meters above 1.5. This is 10.5. And then an additional 9 meters to the top, 19.5. So there's our scale. The maximum is at 19.5, the minimum is at 1.5. Horizontally, 45 is the full cycle, so halfway is this maximum here. Half of 45 is 22.5, and I am going to use decimals this time. Cutting it in half again to find these axis points. There's 11.25, and I'm not even going to worry about this one. I notice it's on a down slope, which won't be helpful for my equation. Okay. Let's move into calculating all the characteristics of the function so we can figure out the equation. Now the amplitude you can calculate using 19.5 and 1.5, subtracting and then dividing by 2. But you're just going to get 9, which is the radius of the Ferris wheel. So I can figure that one out kind of without having to do any of that math, just because I understand that 9 is half of the difference between the top and bottom already. And that's going to be our a value. Possibly a will be negative, so let's put absolute value brackets around that. Looking at our axis, again you could do a calculation, or we already figured out that it's 9 above 1.5, so 10.5. And that's going to be the c value, up 10.5. Now, the period is the most challenging part and is maybe the most important part here, the part that's different. So the period is 45, and that's in seconds. It takes 45 seconds. It's not in degrees. So I'm just going to write 45, and then in brackets I'm going to say it's seconds, not degrees. This is a key point because it's going to affect how we write down the k value. Remember, the k value can be calculated by taking 360 degrees, there's the degrees, and dividing by the period. Now usually that's also written in degrees, so k has no units, but here 45 is not in degrees. We have 360 degrees divided by 45. The absolute value of k is actually 8 degrees. It's written in degrees. We're going to see why that's important when we go to write our equation. Let's start by writing a sine equation. So we're told to find the height. So I'm going to use h for the height. Now I'm not using theta here. Instead we're using time, t, in seconds, and that's written up here. The amplitude is first. Now this is a sine equation. I'm going to write 9 sine. The beginning of a sine curve starts on an axis and moves up. I'm going to need a horizontal translation, so I'm going to use square brackets. Then I write down the k value, 8, and then you put the degree symbol there. It's important that you do that this time. Now in the brackets, usually it was theta plus or minus something. Now it's t. And I've got a horizontal translation, or phase shift, right by 11.25. So that'll be a minus 11.25. Close the bracket, close the square bracket, and then up c, which is 10.5. Now you see what happens here. T is just a number of seconds in this case, so it's 45 or 22 or whatever, minus 11.25. That's all just a number, but sine takes an angle as a parameter. You have to have an angle in here, and that's why k has to be in degrees. There's the degree part. You'll have some number of degrees times a number. In the square brackets, this whole thing will still be an angle that the sine function can use. Let's try a cosine version. I noticed that because we're starting at the minimum, this is kind of a flipped over version of cosine. Cosine starts at a maximum usually. So by doing a vertical reflection, I don't need a horizontal translation. Now I'm just flipped over and starting at the bottom. So I can use cosine, I can use a round bracket, 8 degrees t, that's 8 times t in degrees, and then plus 10.5. So there we have two different equations to represent the same situation. And once again, you could now use this, for example, to say, how high will the Ferris wheel be at 100 seconds? That would be difficult to see on the graph, even by extending it. You put 100 in for t, find h of 100 in either equation, and you'll find out what the height is from then on. Okay, in our second example, we have a saw blade that moves up and down sinusoidally. The top of the blade reaches a maximum height of 6.24 centimeters above the table and a minimum height of 4.86 centimeters above the table. The blade completes 300 full cycles per minute. Write an equation, h of t, to represent the height of the top of the blade above the table after t seconds. Notice the unit change here. And assume the blade starts at its maximum height above the table. Well, we're going to write a little graph here just like we did before. Let's draw this in. We have heights above a table. T is in seconds again. The height goes this way. We're going to use y as our vertical variable. And again, I'm not going to use a good scale here. I'm just going to put in some key points to make it easy for me to make sense of this. 6.24 was the top value, and I know this is not to scale. There's 4.86. If you want, you can put a little breaky thing in there. There's a halfway point we'll have to figure out. We started at the maximum, and we want to go to a minimum, and then back up to a maximum, down to a minimum, and then there's the halfway points in there. It says it completes 300 cycles per minute. Well, we're going to figure out what this looks like in just a moment. Let's just sketch it in, and then we'll figure out the period when we're doing our little calculations. Just like the last one, notice I did not start with an arrow at the beginning, only at the end. Alright, well, we'll get to the period in a moment. Let's begin with the amplitude because it's fairly straightforward. The amplitude is the top minus the bottom, max minus min, divided by 2, and that will be 0.69, so that's the absolute value of A. A could be 0.69 or negative 0.69, depending on how we want to write it. The axis, that's y equals, same calculation with a plus sign instead, averaging the max and the min, and we'll get that C then, this tells us C is 5.5. 0.55. So that's our value that we use at the end, and that's positive, so maybe I'll put a plus sign as a reminder there. Okay, let's figure out this period. When we know it takes, we can finish 300 cycles in a minute, we want the period in seconds. So the period is the amount of time it takes to complete one cycle. And so the units will be in seconds. And in this case, we know that we have 300 cycles in 60 seconds. Now, you can also think about that as we will have 5 cycles per second. But what we don't want to know is how many cycles per second. We want to know how many seconds per cycle, the time it takes for one cycle. So here I know that in 60 seconds I'm going to have 300 cycles. So if I divide by 300 cycles, you can see how the units will work out here. That's 0.2 or 1/5. That's seconds per one cycle. Now we don't normally write per one cycle in our period units here. The period is 0.2 seconds, and by definition that's how long it takes to complete one cycle. Now if you wanted to multiply 0.2 times 300, you would get 60 seconds. So lots of ways to figure this out, but the key is that you want to make sure that you're calculating how many seconds it takes, not how many cycles per second. So we're sort of given the opposite of what we were looking for. Now based on this we can calculate K. The absolute value of K is 360 divided by that number, which is 0.2 or 1/5, and grab a calculator or you can use your brain and you'll get 1800 degrees. Once again, that's 360 degrees, but the value on the bottom is not in degrees, even though it kind of looks like there's a mark there. Let's make sure it's clear. The value on the bottom is not in degrees, so there's no sort of cancellation or dividing out of those of the angle thing. So we have a degree value for K. So let's start writing our equation. H of t equals, well, we're starting at a maximum and we're not told what kind of equation, so I think it's a good time to use a cosine function since we start at a max. The a value can then be 0.69 cosine, no square bracket, we can use a round bracket this time, perfect, because we have no phase shift. 1800 degrees times t, bracket, and then we have plus 5.55. Just so you know, some people will put 1800 t and then the degree symbol right after, and that's also fine. You can move the degree symbol over there if you want. Anyway, that's a great equation. If you wanted to do a sine equation, what you would have to do is figure out what this is here. I guess the full cycle takes 0.2, so that's 0.2, there's 0.1, so this would be 0.15. You'd have to have a phase shift to the right of 0.15 written in brackets if you were going to do a sine function, something like that. Okay, I hope that is good. If you have any questions, of course, you can ask me in the comments down below, and thanks very much.